Next up, please welcome to the stage Lukáš and Miroslav from Ackee Blockchain on how to stay safe.
Okay, so hello everyone. Thank you for coming. My name is Mirek. I'm here with my colleague Lukáš. We are from Ackee Blockchain. So we are auditors, security researchers, and we are also the auditors of the safe contracts, specifically the version 1.4. At Ackee Blockchain, we perform security reviews. We also develop open source security tools. And we host teaching lessons on our university at Prague. So in the past, we've collaborated with some safe-related projects, such as Monerium, Senzo, or Cow Protocol. And we acquired some tips on how to safely integrate with safe contracts. Additionally, we will talk about some of our tips how to use safe contracts as individuals more safely and what security features Safe offers that you can leverage. And lastly, we will discuss ERC 4337 in the context of static analysis. So here's a quick diagram of the safe contract. So we will need guards, modules, and the fallback handler. So I will go quickly through those concepts. So guards function as a pre and post transaction hooks. Modules allow you to do calls and delegate calls through the safe contract. And the fallback handler allows you to extend the logic because the safe team deploys like singleton contracts which you don't want to modify. So when you want to extend the logic of the safe, you use the fallback handler. So now we will talk about integration tips that you should keep in mind when you are integrating with the safe multisig.
Okay, so hello again. And okay, safe is the message sender. As Mira said, if we want to extend the functionality of safe, we use a fallback handler. And fallback handler is a separate contract. So fallback handler is not inheriting from the safe. Safe is not inheriting from the fallback handler. It's a separate contract, and we need to use it that way. So what's the flow of using it? We basically call the safe address with a function that's implemented in the fallback handler. And because this function is not included inside of the code of the safe, the call will fall into the fallback. And the fallback of the safe will forward the call to the fallback handler. And at this time, inside of the fallback handler, if we use message.sender, message.sender is the safe. It's not the original sender. And why this can be a problem? Because as a developers, and we are used to use message.sender everywhere for access control or, for example, as a keys for mappings and so on. But we have to keep in mind that in this specific scenario, message sender can be someone else than we thought. And to get the original message sender, we have to use the function underscore message sender, which is implemented in the safe. And this function is going to give us the original message sender of the call.
Yes, I will add that this can break our developer mental models because we are used to extending contracts via inheritance, not via adding new external contracts. And because we use message.sender for authorization, authentication, this can break a lot of security-related stuff. So this is a fallback. It's assembly. We just show here that the original message.sender is passed to the fallback handler, but that's a technical detail.
OK, so the next one, TX origin. A lot of developers are trying to avoid this pattern, but it's still quite heavily used, especially inside of the NFT projects. And they use it because they want to check that no bots are going to mint the NFTs. But TX origin can slow down account abstraction adoption a lot because Caller can be a smart wallet, not just externally owned account.
Yes.
Sorry.
In AA, we basically decouple the verification into checking signatures, and normally we do it via checks on message.sender. So this can again break a lot of like the basic flows. And if we want to adopt AA more quickly, we should try to avoid these patterns.
Okay, another one, broken guard. Guards are, again, it's a separate contract, and we use it inside of the safe to perform some additional security checks. And this contract is called inside of the safe execution function, and it's called before the actual execution and after the execution. It performs some checks before and after the state of the safe has been changed. But if the guard is broken, you cannot perform like execution from the safe. So it can cause denial of service. What you should do, you should think about the recovery mechanism before you adding a guard contract. And what can be the recovery mechanism? It can be a module. Module is a contract that can execute function same as the safe, but it doesn't need all the signatures. So how we, like if we have a broken guard and we find there is some bug and the transaction is reverting all the time, we may think that we can change the address of the guard or we can add a new module. But we actually cannot do that because to do this, we need to perform a safe execution. And this execution is broken because the guard is reverting. So again, the module has to be added before we are adding a new guard to make sure we can mitigate this scenario. And I will just mention that in the safe version 1.5, there are also guards inside of the module transactions.
Yes, so there are three things. Always test, audit, and firstly add a mechanism how you can turn off a guard if actually those first two precautions go wrong.
And this is just, as you can see, the authorized. This is the modifier that allows only to perform a self-call, which means that safe can only call itself to execute its functions. So we cannot set guard when the execute function is broken, and we cannot enable a new module. So that's why we have to do it before we are setting the guards.
Yes, exactly. So we mentioned that modules can perform calls and delegate calls on or through the safe. And because of this, we can consider modules to be like even more powerful than the owners. Because in the code path through the modules, there's no signature verification. There's just one top-level call from the module and no verification of the owner signatures. Also, delegate call, the modules can perform like arbitrary address delegate call, and through delegate calls we can corrupt the storage of our contracts, and like the worst scenario is like even self-destruct, which would completely destroy the safe. So what can we do about this? We can get inspiration from a set of libraries developed, for example, by Zodiac, and those can be used to limit the impact and behavior of the modules. And if you decide to use modules, be sure to properly test them and audit them. And if you decide to use delegate calls, which I really strongly advise you not to do, be sure to check that no storage collisions can happen. Another thing to keep in mind is that in AA, we basically decouple the verification from the message.sender. So for example, in the context of ERC 4337, the message.sender will be the bundler. So the verification is done by checking the signatures. And if I, as an owner of a safe, make a transaction, I will send it to the mempool, and it will be sitting in the mempool. So anyone can take the inputs to this my transaction, can take the signatures, and copy them to his own contract. And inside his contract, he can call my safe to actually perform the state change that I authorized by signing the transaction in the first place. During the summer, I actually found exploit related to copying out signatures from mempool. It was unrelated to safe, but it's an attack vector that you have to keep in mind, because many developers can expect that a state change inside the safe can happen only via a top-level call. So if at the beginning of your transaction you check a state of the safe and you then expect that this state will stay the same, well, this assumption can be broken, because if you make an external call, this external contract can use the signatures that the attacker copied out and can change the state of the safe, and thus the invariant, the assumption that you as a developer had, can be broken. Well, how can we avoid this? Safe allows you to use guards, and one of those guards is only owner guard. And this guard will require that the caller is one of the owners of the safe. So in this section, we will provide you with some tips how you can use your personal safe in a safer way.
Okay, so use your own safe. Like, you don't need to have a big DAO or organization. You can use your safe on your own, just as a one-of-one multi-sig wallet. And why it's good? Because it's secure. You have the one address for all the time. You can rotate your keys. You can add the new owners later. You can use your hardware wallet as a second owner address and increase the threshold for signatures to 2. You can like update verification mechanisms, or let's say you can create your own recovery mechanism, and you can change all these things in the future, but your address remains the same. So try to use your own safe.
Yes, this is a good point, because you can rotate your key, but you can keep your constant address. So for example, you can keep your positions inside your DeFi protocols, and you don't have to perform any complicated transfers. So this is a really convenient way how to increase security of your funds while keeping the overhead, the technical overhead, at minimum.
Okay. Transaction simulation. Like the code of the safe, it implements the simulate function. And this function basically simulates the safe transaction execution. It reverts at the end, but it gives you all the stack traces. It can events logged during the execution or state changes. So if you simulate your transaction, you can get like much more confidence before actual execution. For example, Tenderly having a good UX where you can use this function and you can see all the state changes, as I said. So it's very good before you perform any like important transaction, as for example, moving a large amount of your assets. Or you can also use another third-party product, which is called DeFirewall by Redefine. And these things basically do the simulation for you. And so if you want to execute some transaction, so before signing the transaction, pop-up window will appear, and it is going to tell you if there is some potentially malicious thing happening. For example, if the recipient address is some address known from the previous hacks, or it's a blacklisted address, or it will show you that what state changes are going to happen after the transaction. For example, it will show you that all your balances are going to 0, and it will ask you if you really want to continue with execution. So it's a good way how to notify users that they may be in some malicious website. Let's say you're using your favorite AMM website, but it's controlled by some hacker at the time, and it makes you sign the transaction. And as we know, like looking at the transaction data is pretty difficult because it's not obvious at all what are you signing. So this can help you to being hacked, basically.
Yeah, so I would like just to add that if you're considering using Safe, this is directly built inside the UI. So you get this for free without any work, and it's extremely easy and convenient to use.
Okay, this is a simple advice. As I said, if you have your own one-of-one multi-sig wallet and you want to increase the threshold and you want to add a new owner, Safe has a function that can do both these things in one function, one transaction. But if you make a mistake, you put there a wrong address, and the threshold will be increased to 2, then your safe is basically bricked because your second address is not working. It's some bad address. So just a simple mitigation. First, add a new owner, and as a second step, increase the threshold. And if you call the increasing threshold function with a new owner added, you are sure that you made it right.
Yes, this is extremely easy to perform, and you don't have to write any code, any verification tests. So it's like very convenient even for non-technical people. So another advice is that as Safe is getting more and more popular, third-party deployers will pop up, and that's problematic in a way. So Safe uses singletons. That means that each Safe contract is deployed once, and for you, you have just your own proxy, which points to the singleton. However, the singleton contains a setup function, and inside this setup function, you have a delegate call. And again, with delegate calls, you can have arbitrary state changes, etc. So if you use a third-party deployer, you, for example, have to trust that although he will use the singletons, that he won't supply any malicious target address to which he would delegate call. So if you're deploying safes, and you're not technical enough to do it, for example, via scripts, always try to do like bare bone deploys with minimal feature set. And ideally, you would check the input data for the deploy transaction and, for example, even verify the traces of this deployment. So at Ackee Blockchain, we are developing a testing framework, development framework, static analyzer, language server, and many detectors that, for example, you might know from Slither. And we also want to make it easier for developers to start building ERC-4337 compliant contracts. And for this reason, we decided to create a detector for forbidden opcodes. So in this ERC, you basically have this entity which is called bundler, and the bundler pays like the initial fees, and he has to verify that he will be actually paid back. And to be paid back, like he needs to simulate the transaction by himself. However, to have guarantees that the simulation will be like deterministic, that the simulation will equal the actual on-chain execution, some of the opcodes are forbidden. And it actually can be tedious to check whether our code is compliant. So we will add a detector inside the language server for solidity. And the language server or the detector will analyze the AST of your code base, and it will check whether you don't use any of those forbidden opcodes. And if you actually do so, it will point to the statement or expression inside your source where you do so, and it will give you a warning. So if you're interested in this tool, here's a link to our GitHub.
And I will just add, sorry, at the end that we will release like the blog posts in the upcoming week with all these like tips and a few more, and with resources, which may be like a good way. And you can use it as a checklist while you deploying or building around Safe. May be useful.
Yes, exactly.
Thank you.
Thank you very much for the attention.